Let's go. Hey y'all. Hey y'all. Let's do a live curtain in celebration of the Mars Rover Perseverance, who is, I guess, about to land at some point today or soon-ish. I'm following it on the screen next to me, so when it's time, I hope yeah, I can follow that stuff. But in the meanwhile, I thought, why not do a Code Kata, which is the Mars Rover Code Kata. Actually, it's a fun one. It's my favorite, and yeah, why not? So, but first of all, cheers. Mm. Mm. Mm-hmm. Mm. 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 If you want to follow along, go somewhere. Go here. Hang on. Let me real quick share you a link where you can follow along. Well, not follow along, but also do the Code Kata. It's right there. You can start it off, clone the repository, and you're off. But yeah, so first things first is let's build a rover with a position and the direction that it's facing. Oh, why not? We've got some setup here where we are returning a hello world. We don't really need this at all. So let's get rid of a bunch of stuff first, maybe. Then we'll just call this the Mars, or to mark it really, Perseverance test. I hope I spelled that wrong. Right. Perseverance. Seems like I did it right. Okay, so the first thing is a rover has a position and a direction that it's facing. Okay, I think we can make that. A rover has a direction, no, a position and a direction that it's facing. So stuff that we don't know yet, in fact, because I haven't told you. Or maybe also like the full rules of Mars Rover Kata. Oh, I thought I linked. Ah, yeah, no, I think maybe they are here. Yeah. Let's go here. There we go. So there's a rover kata here somewhere. I swear. Gonna guess it's in the TDD one. Ah, here it is. You are giving a starting point, X, Y, and a direction. That's it. The rover receives a collection of commands. Maybe we can do it a bit different now, since we are witnessing the landing of a rover. Maybe what we can do, a rover lands on, and then maybe also not just any rover, let's call it Perseverance, lands on a position and a direction that it's facing towards, maybe. There we go. So I don't know, maybe there is a thing called land. I guess a rover will be in flight at some point or something, so maybe we'll do something like land, and then we'll pass along Perseverance itself, or it doesn't really need to have the name or the rover itself. So let's just pass along a position. We'll make them start at here, and then a direction facing Oh, let's just do it like that. North. There we go. Then we can make that more explicit later. So for position, let's just make a simple data class where we've got two values or two integers, an x and a y. There we go. And then we've got a new function called land. We need to put it somewhere. So let's just put it somewhere outside of the test. So land. It will take a position, a landing position maybe, which is a position, and it will take for now a direction, maybe a facing direction, which is a string. And what does this thing return? I guess a rover, a Mars rover or a rover. That's it. And then a rover needs to be something, so we'll also add that as a class with no fields, maybe a name, I don't know. And the default one is perseverance. There we go. Then we should just return or mark it as to do. There we go. Okay, then this is returning something. It should be the landed perseverance. So we are writing history here. Huh? I'm just kidding. I'm so sorry. And we can assert that the landed perseverance is equal to a Mars rover with name perseverance, and we'll need to import that that statement from assert j, which is my favorite assertion library, and then this should be all. But then really what we also want to do is pass along some other stuff, because the position and the direction that it's facing towards, we'll say that it landed at position 0, 0 and facing north. So let's do that as well. Call it pulse facing north. Something like that. Seems good? Let me know, by the way, if you've got any suggestions on how to improve my code, or the approach even. But just keep in mind that I will be refactoring some stuff as we go along. Okay, so this is compiling. That's nice. What's not compiling yet are these things here. So we'll need some kind of position thing for our rover here. So let's call it a pulse, which is a position, which we don't yet give it a default. And then this is just a string for now. That's it. And then we can run this code. And then hopefully notice that it's wrong, because, well, we should be failing because it's still to do. Now, Kotlin is a bit slow at the startup, but once you get her up and running, it should be going much faster. It also could be that I'm not actually running my tests via IntelliJ, but via Gradle, which is also going to make it a bit more slow. Now maybe something is wrong. I don't know what's going on here. Maybe it was because no, these are previous tests. Yeah. Okay, here we go. An operation is not implemented. You are correct. So let's return a Mars rover with perseverance at was something else. just to verify that that stuff is working, in fact. Nowhere. And run the test again. Then we will be sure to see what's going on here. So I'm also quite sure that this is exactly how the engineers at NASA developed code to actually code the Mars rover. Of course, that's not true. I'm just kidding. And then what do they do? Okay, so Mars rover position x1 should be equal to 0, 0. So it's failing for the right reason here. So let's make it work. I could do this, but really what we should be doing is, of course, use the landing position parameter and the facing direction here. There we go. And then the test should work. So then I think that will be a nice moment in time to commit. Nice. So I created a separate branch. Let's do, I don't know, rocket or something, or tada. Perseverance can land on a position facing in a direction. Nice. Then
Nice.
hey. Then what's what the
I just wanted to say
hi. Hey. Okay. Then the next test we will do is not a readme. I want a rover.md. So this we can mark off as done. Maybe make it a little bit nicer. There we go. You can barely see it, but the checkbox is checked. The next thing can receive a forwards command, changing its position. So with regards to that, let's create a new test saying Perseverance can receive a forwards command. And move towards a new position. So the implementation of that should look a bit like this, or like the test, I mean. So first we will land our rover. Or wait, I made a big mistake. At this point, I didn't make the refactoring step. So maybe let's do that first. Let's see. What we could do here. Yeah, so facing now, it's not very cool, I guess, that it can face north. I mean, it will just take the position, or the facing direction, sorry, that's been passed here to the land thing, but I guess direction is something that is going to be a bit more interesting later, I guess. Maybe let's do it when we need it, actually. So for now, let's just keep it a string and then see how far we can go. All right, so we'll need again a landed Perseverance. And then what we'll need to do is say landed can receive a forwards command. So maybe we'll just do receive forwards and move towards a new position. So now we've got we can choose how we are going to verify that the position was changed, basically. So either what we can do is we'll just assume that a rover is something that the Mars rover can talk about itself. So when they receive a forwards command, I suggest we'll just say updated rover or something like that. And this one should contain its updated position. So we're using immutability here. And then once that is there, then I can say, well, my updated rover should be equal to, well, my it should be a Mars rover, and its position, which is the most important thing for this test, is that it should move up the y-axis because it is facing north. So x should remain the same to 0 and y should be 1. So moving up 1 square. We are living in a very simple orthogonal world where yeah, it doesn't matter, or it's just easier to reason about, let's just say, to keep the kata simple as well. Next thing we'll need to do is make sure that its name has remained unchanged. So it's still perseverance, and then its facing direction should also remain unchanged, which is north. And that's the test I want to write. Now we'll need to make it compile. I don't really know why this is bulking. Ah yeah, so it doesn't really know what updated rover is, so let's make that more explicit maybe. Then it should fix that error. Okay, so this part is compiling. The receive function is non-existent, so we can create that. The S here is a command. It's a string. It's gonna return a new Mars rover, and we have not implemented it yet. So let's run the tests, and making sure that everything else is just working correctly. Alright, what's up next is we can just maybe, to make it super simple, return yourself. And then the test should also fail, I guess, because we haven't updated the Y position. Noise. So to make it work, what I could do, because I really want to make sure that the rest stays the same, since Mars Rover here is a data class, I can use the copy method that we get on data classes, and then use name parameters to only update the position. And here we'll just give a fixed position of 0 and 1. So sort of hard coding it, but we are making it work that way. Or we should be making it work that way, I guess. Alright, that's green. And now we could refactor again. I don't think we need to really do that. But another test we could write here is to verify that if you call forwards on this thing again, that we then update the position again. So really, maybe we can write that in a separate test first, just to make it super explicit. Twice. Yeah, so because it's an immutable object and receive is returning that object again, I can call forwards twice, and then the position should be updated to this. Now let's run it again. And this test should fail. So now I can no longer just update or hard code the result into this, because if I do that, then my previous test will fail, of course. So just to make sure I'm not spouting nonsense, here we go. So we can't just hard code this, now we need to calculate this stuff. So what I suggest we do is since we are only still moving north and moving forwards, what we could do is just update this position's y-axis. So this one is equal to, and then we can copy the position field, in fact, and then only update y to this dot pos dot y plus 1. So again, it's a bit dirty, but hang in there with me. There we go, it's green. So now it's working. Now we need to refactor. So what we can see is this chaining is a bit dirty. But what I'm really doing here is with this method, I'm updating only the y position with 1. So I'm moving up the y-axis, we could say. So if I want to refactor that, I could extract this into a method saying move up the y-axis. Just spell it out first. Maybe we need one, or not really. We could add this as a step parameter to make sure that it's very explicit. So now we are moving up the y-axis with 1 step. Seems good enough for me, or as explicit enough for me is what I wanted to say. But the other thing that we were doing is that we are still accessing the copy directly on the position, and I don't really like putting the responsibility of updating itself outside of itself. So more concretely, I don't like that it's Mars Rover's job now to update the position itself. So what I really want to do is I want to say, well, basically I want to move this here to, so like this, move up the y-axis with step. I noticed that they were clapping, but I don't really know why they were clapping. What's going on? Maybe it landed and I missed it. I guess that we don't really have visual. I didn't really think about that. Yeah, so what I want to do is move that to the position. This should return another position again. And then I can say return this kind of stuff, but then without the pos. So we just replace pos. Okay. There we go. Maybe let's listen in a bit on what these folks are talking about.
From students, well, a couple weeks ago, Marina was able to catch up with them.
Oh, more questions, I think.
Earlier this year, NASA and our partners held a nationwide essay contest to name our Mars rover.
Oh.
Alex Mather, a 7th grader from Springfield, Virginia, submitted the winning essay that was selected by NASA from a field of more than 28,000 entries from K through 12 students in every state in the U.S. Vanessa Rupani's essay.
Naming is difficult. I can tell you.
NASA thought it would be a perfect name for the history-making helicopter, a technology demonstration carried aboard with Perseverance rover. Alex and Vanessa join us now. Welcome, you guys.
Hello, space nerds.
This guy is awesome. All right, let's mute it. I'll check back in later. Where were we at? We were actually finishing up. We've got green tests, so we've done some refactoring, which is nice. There we go. I guess I didn't really need this now that I see this here. Actually, we don't really need this name at all because it's not going to be that important yet. Okay, the thing I'm going to do is I'm going to rename Mars Rover to not just any Mars Rover, but call it Perseverance. There we go. And then let's roll that back and do a refactor and delete property. Okay. Goodbye name. Then we'll rename Mars Rover to Perseverance, and then it's much more safer. Much more safe? Much more safe. We don't need a type here anymore. There we go. Nice. This is good, this is good. It's good. Quite good. Yet another refactoring we can do is right now. This receive is doing nothing with command. But really what this is, it's already hinted at a bit, I guess, with the move up the y-axis. So maybe I can already extract this into a move method or something, but we don't really have the need for it. Okay, that was weird. But this should be okay already, I think. Alright, looks good. Let's make a commit, I guess, because we're... let's first maybe write another test where we try to break it. Cannot receive garbage commands, or it will balk. I don't know why I chose that word, but it just came to me. So this is literally garbage. Then I don't want anything to happen at all. What do we want to do? Bulk is basically doing nothing at all, so maybe we can just return the rover itself. Or maybe what we could say is like, hey, this is not something I understand. So I guess in a real life situation it would be interesting to do that. But for now, maybe we can just verify that it remains the same. So it remains at position 0 facing north. Then if I do this, I guess it will fail. There we go. Because it actually did move, and I don't want my rover to do that. So I wanted to evaluate this command here. So the way we could do that is by checking with a simple if command, or maybe more like this. Oh, this is my Java developer kicking in now. My experience by putting the string first as the first argument. We don't really need this, so let's do it the other way around. So if it equals forwards, I think. So this is already a bad way to do this, but we will fix it later. We shall return this, else we shall return this. So a copy. Right, we can do it like that. Okay, nice. Thank you, IntelliJ. Now if we run the tests, I might have not run all of them. Yeah, I didn't run all of them. Let's run all of them. Control-Shift-R, run all the tests. There we go. Now they're all green. Now one thing I already, or you might have noticed me doing, is that, okay, just before, let's move stuff like that. Oops, not what I wanted to do. There we go. You can already notice me struggling with, was it 4 words or forward? I don't really remember, so that's like a bad thing. If I made a typo here, it wouldn't have worked. So I don't want that stuff to happen. The other thing that I don't want to do really is like have magic keywords here. Makes sense, right? So maybe let's just skip the parsing of strings into some actual actual commands into making this into a type. So let's call it a Mars Rover command maybe. And then a Mars Rover command can be something like this, forwards. That makes a bit more sense, I think. Or it will be safer, is really what I wanted to say. I don't know why I started writing data class. It should be maybe an enum class in the beginning at least. And then here's your name, forwards. And now we just need to fix all of this. So all of a sudden I can't put garbage in here anymore. So this entire test just becomes useless, because now I just made sure that you can't pass garbage commands to perseverance. So this is something we want, that because less tests means less maintenance, means better code. So there you go. Let's change all of these into Mars Rover command forwards, and maybe already do an import for that. There we go. Let's run the tests again. Yay! All right. So do we still, or can we still find some other refactoring here? We could switch this up a bit. And first, yeah, actually, now this stuff doesn't make sense anymore because there's only one command that we can send. And otherwise we can do this. So this really makes absolutely no sense anymore. And because the command, it cannot be something else, at least not for now. Yeah, so let's keep it that way. And then just do this. Return. Run the tests again because we just changed some stuff. Okay, there we go. Now let's make a commit again. Now it can move forwards up the y-axis. And now we can try out 2 things. What's this, the review? Oh, the test contains problems, eh? Yeah, so this one is always 1. I think we can just remove it then. Makes more sense. There we go. Now, I guess this one is never used. We'll get to that. Now let's make a commit saying that the perseverance can move up, forwards up the y-axis, comma, just like that. And then maybe we can. No, I don't want to check that feature just yet. So let's commit it. There we go. The thing that I didn't do now is to check. What was it again? To check. Yeah, if we can clean up our tests, really. We sort of did that already here with the landed perseverance, but this is always going to land at 0, 0 and north, so maybe we can also refactor this. and just use that as a base for all of our tests. But maybe it's a bit, it's okay still, because we're otherwise we might lose being very explicit about what our perseverance looked like before and after our tests. So now we've gotten two things here, or we've got options, I guess. That's not what I wanted to show. This readme here. So now we can ask ourselves: are we ready with a rover can receive a forwards command changing its position? Now, notice that it's not saying anything about which direction it's facing or anything. It's just saying its position. So we always what we will say is that a rover will move in the direction that it's facing, though. So let's do that first. So we can still keep forwards, but if we land the rover while it's not facing north but maybe south, for example, then we don't expect it to be facing, or it should still be facing south after that. But we want the y position to be updated to -2, so it's moving down the y-axis, which you haven't done just yet. So while facing south, and move towards a new position, or move down the y-axis, I guess. And then this should be move up the y-axis while facing north, and move up the y-axis. Now you can already see the next tests that are going to be there are, well, if it's east, then it should be the x-axis, and if it's west, then it should be also the x-axis, but then down and up again. Okay, so now we've got some choices. Let's maybe first create those and then leave them unimplemented, just so that we know that these are still tests we need to actually write. While facing east, when east means up the y-axis, and then west means down the x-axis. There we go. Looks like it was still hovering outside of Mars, so I guess everything is okay. Okay, let's first implement this one. Let's find that these fail. Or, well, don't do anything yet, in fact. There we go. Why did it fail? Well, because it's expecting -2, but in fact it's just 2. That means our forwards command is not exactly doing the stuff that it needs to do, because it's always moving up the y-axis. So the next thing we should try and do, I think, is to figure out what the direction is that Perseverance is facing. So you already saw I'm passing down just strings, but really we're going to end up in the same situation as I already did before, where you could pass any kind of garbage as a command to your rover, and I just want to skip ahead a bit and then just notice that facing direction, it's not just a string. Facing direction is a facing direction. And facing direction can also be an enum, which consists out of north, east, south, and west. There we go. Now we'll need to first make it compile. So I am doing changes as I'm in a red. So maybe let's make this work first. Should I do that? Yeah, let's make it work first. We can write that later. Okie doke. So we can just check for now. Return if facing equals north. Well, then it's okay for you to move up the y-axis. Else, move down the y-axis. I'm going to write down the y-axis. That doesn't exist yet. We'll write that here. Delegate it to pos, which also doesn't exist, which we'll just create here. Down the y-axis, and then return negative. It did remain, or did keep the step here. So it's strange that it's not complaining about that, because that's also always just a single step. It's a bit weird. Okay, I'm gonna guess that it's going to work. Nice. Now what we can do is make this a bit shorter, just like that. Then it's a little bit easier to read, or at least I think so. So all of my tests are green. Let's do that refactoring you spoke about earlier, where we are making this into a facing direction, where we'll create a type to make sure that we can't just pass garbage into that land function. West is left. Alright, now we'll need to change this into a facing direction type, and then here we can just say when it's north. Maybe I can also make it look a bit prettier. I'm not sure. Normally enum classes, the convention is that they're always uppercased. I don't really know why that is still a thing, and I choose to not comply. So screw that mess. Let's do it like this. Or if you can give me any good reason why I should uppercase that stuff, just let me know. And I guess I'll consider it. It's okay. Ooh, we noticed some other stuff, or I noticed some other stuff, but let's first fix all of these. So all the norths here, they can be replaced with this, which is the north from the facing direction, and then we luckily only have south. So, oops, let's also get rid of that. So voila. You know, like south, the longer you look at this word, the weirder it becomes. It's like S-out, H, outh. I don't know. Kind of weird. Might also be the whiskey talking. Who knows? Who knows? Anyway, we're in green, so we can commit now, because now we've changed it that they can also move south down the y-axis. So I guess we can start implementing these. Maybe we'll make a little commit. Can move, but then down the y-axis. So now it's still up and down the x-axis that we need to do. So for that, I guess we can copy a bunch of stuff from here. And then verify that if this is facing east, that's the test here. It should remain facing east. Y should be 0. That should be the import. That is correct. We can statically import. And then we can, that should not be 9, but 0. And then X should be updated to 2. This is likely going to fail. Ah, dang. I think I ran only that one. You may enjoy a 10-minute break. Oh, is it landing? Is it about to land? Okay, thanks for the heads up. I will I've got it open, so let's watch it land.
I have confirmation that we got shadowed by the cruise stage as it passed through our beam to the Earth.
Telecom indicated actually that we could see a signal that the cruise stage went between the Perseverance entry capsule and Earth. So we saw a little blip, the data stream indicating cruise stage separation. We have confirmation that the vehicle has started warming up those entry thrusters. Warm-up pulses have begun. At this point, the spacecraft is trying to stop its spin from the cruise 2 revolutions per minute down to 0, and then will turn to its desired orientation from entry. It will separate the 2 balance mass that has kept it balanced during all of cruise. This will allow the entry capsule to have lift.
This is so cool.
It enters the atmosphere. We have confirmation that the spacecraft has turned to the desired entry attitude. We are about 7.5 minutes from entry interface.
I wonder how they made that presentation.
Pointed in the right direction. Thrusters are warmed up and doing their job. And now we've spun down from 2 revolutions per minute that the vehicle had the whole way to Mars as a spin-stabilized spacecraft. And then from here on out, it's going to just be a bullet, and it's going to control its orientation and attitude via rockets on the back of that back shell.
Points carrier lock. Sorry, the DTE from Radio Science from Greenbank reports carrier lock. Do you see the carrier?
Now one of these people is gonna do a call to this here function, land.
We are continuing to wait for entry.
Oh yeah, the speed of light delay. It might have already happened.
We have confirmation from Greenback that they are receiving direct to Earth telemetry via that path. The spacecraft Perseverance is currently transmitting heartbeat tones. These tones indicate that Perseverance is operating normally and has nothing significant to report.
Oh, that's sad.
This is as expected. We're currently just...
They're not going to call my land function. But mine is tested. And it will put the rover at position 00 facing north. Attitude control.
At the top of the atmosphere, it'll be very quickly, which is the entry point. It won't be very long before the atmosphere will start getting thicker and thicker. It's going very quickly at a fairly steep angle of 15 degrees into the atmosphere, and as it starts to slow down.
Just under, we're about 5.5 minutes from entry interface. We're still receiving heartbeat tones. We expect to continue receiving heartbeat tones until about 5 minutes after entry. At that time, Perseverance will be no longer in view of our antennas here on Earth. About 90 seconds prior to entry, the Mars Reconnaissance Orbiter should begin receiving telemetry from Perseverance and streaming it to Earth in near real time.
That's so cool.
There are a few expected short outages, such as when we have a plasma blackout or when we enter the peak heating phase. Aside from these outages caused by the plasma blackout, antenna switching, or high dynamic events, spacecraft events, we should have telemetry until about 90 seconds after landing. A plasma blackout is when the signal from Perseverance isn't strong enough to make it through the superheated, super fast air flowing around the spacecraft all the way down to Earth. Once the temperature drops below that peak heating, we do reacquire the signal from Perseverance.
Damn.
We are currently about 4.5 minutes from entry interface. Perseverance continues to report heartbeat tones, indicating everything is nominal.
Okay, what we're looking for now is Mars Reconnaissance Orbiter should be in view soon of our vehicle and be able to listen to ones and zeros coming from a separate radio. That's really
11 minutes delay. It's already landed then.
The electro radio is powered on, ready to receive signals from the lander.
okay. MRO is ready and able and waiting for to hear from our rover.
Mars Reconnaissance Orbiter has reported that it's ready to receive the signals from Perseverance. It should be in a few minutes here. We're just
Flight local 1
from entry interface.
We don't need these ones and zeros, as Swati said, but to land safely. But we really need it for our own health and well-being today to keep our nerves in control.
This guy is amazing.
We should begin picking
We
up
need
more
it for our own health.
and we'll continue to record
I love that.
telemetry until several minutes post-landing. We won't get that data for several hours after landing as it's
Oh.
being recorded, and then will be forwarded to Earth later. We are continuing to receive heartbeat tones, indicating that everything is
So I
normal.
guess they will only know, even if stuff goes wrong,
Until entry interface.
in 14 minutes that they will know that something is wrong then, I guess.
Very soon we'll be getting ones and zeros.
I mean, assuming that the signal also travels at speed of light.
The entry interface is nothing more than just an arbitrary place in the sky that we've defined to be above the atmosphere. But from that point on, there's definitely
They're really doing a great job explaining all of this stuff.
Minutes from entry
It's so
interface.
nice.
Perseverance is to transmit heartbeat tones, indicating everything is nominal.
It's so
so the tones can tell us whether something's bad or not is happening. So far the heartbeat is doing well. So the vehicle thinks it's in good shape to land, which is a great sign.
which is a great sign. Man, I really hope nothing goes wrong with this. Why haven't I not liked it? Oh, they're talking. Something's up.
Under 2 minutes from entry interface. As it gets closer to Mars, Perseverance is actually being pulled in by gravity and accelerating. By the time Perseverance reaches entry interface point, she should be going just under 5.4 kilometers per second. We're at about 90 seconds from entry interface and standing by for Mars Reconnaissance Orbiter to pick up the telemetry.
Let's go. It's a cool looking emoji. It's nice.
We are 1 minute from entry interface.
OMG, I am excited. She also looks really excited and nervous.
MROs are in receive mode.
Bunch of thumbs ups.
We have confirmation that the Mars Reconnaissance Orbiter is now relaying data from Perseverance.
Oh, what?
30 seconds from entry interface. Perseverance is going about 5.2 kilometers per second and is about 190 kilometers altitude above the surface of Mars. Confirm UHF data flow.
Oh no, it's lagging. Oh, there we go. Wait for entry. I wonder what this stuff is.
Seconds from entry interface.
Like guidance programs, maybe?
5.6 kilometers per second at an altitude of about 150 kilometers from the surface of Mars.
Done. We're only at the very beginning, actually. Holy.
We have confirmation of entry interface. Perseverance is currently going 5.3 kilometers per second at an altitude of about 120 kilometers from the surface of Mars.
It's so funny that they keep on saying currently and not was.
The system is now waiting until it begins feeling the atmosphere of Mars slow it down. Once there is enough atmosphere, it will start controlling its path to the landing target. Navigation is also confirming that we can see a little bit of that slowdown of the atmosphere on the Perseverance entry capsule. Our current velocity is about 5.36 kilometers per second and an altitude of about 67 kilometers from the surface.
We are probably seeing MRO at this point.
Oh wait, suddenly the rest of the program
Right now.
MRO has lost
was running much faster.
Perseverance. We have indications that Perseverance
Yeah, it is more
now
comfortable to use
performing
local
bank
reality.
reversals in the atmosphere. These are the steps in order to control its distance to the landing target. Perseverance has just passed through the point of maximum deceleration and has indicated that it felt approximately 10 Earth Gs of deceleration.
MRO has lock again.
Yes.
We saw a small outage of the UHF telemetry from Mars Reconnaissance Orbiter during that peak heating phase, likely caused by the plasma blackout. Still continuing to perform bank reversals in the atmosphere to control its distance to the landing target.
I also like that they use the word felt gravity. It's like this Perseverance has like a human human aspect to it as well. It's so cool.
Perseverance is going about 1 kilometers per second at an altitude of about 16 kilometers from the surface of Mars.
Whoa.
We have entered heading alignment, which means Perseverance is no longer trying to control the distance to Mars, but to the target on Mars, but instead is flying straight to the target.
Oh yeah, okay. So now it's above the crater, I guess, or something like that. Imagine esports commentators doing this. Yeah, it's really important. Maybe someone should make a clip of or overlay a clip of
Our current
Artosis
velocity
and
is
Tasteless.
about 550 meters per second at an altitude of about 15 kilometers from the surface.
MRO's reporting good telemetry log.
We are coming upon the straighten up. We are
Ah,
starting to
it's
straighten up and
a
fly
her.
away
Okay,
maneuver,
cool.
where the spacecraft will jettison
I wasn't
its
really
three
following
ground
before.
passes in preparation for parachute and to roll over to give the radar a better look at the ground. The navigation has confirmed that the parachute has deployed and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Good job. This is so cool.
Perseverance is now slowed to subsonic speeds and the heat shield has been separated. This allows
Yo.
both the radar and the
Thanks for
camera
the
to get
cheers.
their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Yes. Yes. Yes.
Perseverance now has radar lock on the ground. Current velocity is about 100 meters per second.
Yay, it's landed!
0.6 kilometers of the surface. Perseverance is continuing to descend.
I know it's not landed yet.
We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is
Radar lock.
90 meters per second at an altitude of 4.2 kilometers. We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Ah yeah, so it scans.
We have priming of the landing engines. Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
Here in Safety Bravo.
We have completed our terrain relative
Damn, that's
navigation.
nice.
Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars.
Wow.
We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver.
We've lost direct to Earth tones.
As expected.
Sky crane maneuver has started.
Ah yeah, I remember this from last time.
We're getting signals from MRO.
UHF is good.
The premature clap.
Perseverance.
Yay!
On the surface of Mars, ready to begin seeking the sands of past life.
Good job. Huh? Yeah.
At this point, the descent stage has flown away to a safe distance. Perseverance is continuing to transmit direct through Mars Reconnaissance Orbiter to Earth.
This is so cool.
Oh my god.
So much work was put into this. Imagine, honestly, imagine if this was like a software development team and they were cheering like this whenever their product went live. Oh my god, what the hell?
This is so exciting. The team is beside themselves. It's so surreal.
Really well done.
Get some pictures.
Is it really surreal though? I mean, I guess I don't really know what all of the stuff there is that can go wrong with this, but you know.
So much has been riding on this.
Nice.
Yeah, we just heard the news that Perseverance is alive on the surface of Mars.
Sweet.
It's not
Flight, we have seen the completion of EDL 3000.
Copy activity. That is as expected.
Man.
MRO is still seeing a strong signal from the lander.
Amazing crew. Really. Nicely done, folks. Alright, let's get back to it. Let's just get back to it. I can't leave this untested. Let's get back to writing silly unit tests to try and get better at writing software. Oh my god. Yeah, you're right. Seeing a room full of guys smoking in comparison is mind-boggling. It's true. What's going on with this again? Ah, yeah, you're facing east. You want to move up the x-axis. The test is there. It's failing for the right reason. Because it's still thinking that it should move down the y-axis. So I guess now I could go like this. Oh, so that was a JavaScript typo there. And then else, I guess, we'll do... Oh, is it like this? This doesn't exist. No, I mean, I don't want to do this anyway. Hang on, let's use refactoring tools for this. There we go. Now let's make this into a when expression. There we go. And now we can just gradually make this nicer. Now IntelliJ is going to say me, or the compiler really, add necessary east-west branches. Exactly what I wanted. We're doing east only now. So let's do east. And then say you should move up the x-axis, which doesn't exist yet. Maybe something I wanted to do, which I'm not really sure if I want to do that. Because this really is just delegation. I could inline this stuff. I mean, there needs to be a nicer way to do this, in fact. But else just return this. That makes it compile and not fail. And then we can write yay. We can check if the rest is also still working because I only ran one test. Yes, it is. Okay, I guess that takes care of that. So can move forwards up the x-axis. There we go. Ja, jong, commit. We're still not doing anything with that command, so that's why it keeps on complaining. Okay, and then the next thing is to do this with west. It should still be facing west, but it should be -2. And if I rerun all of the tests, this one should fail. It should be the only one that's failing. Yeah, nice. And then we can just say, hey, when it's west, move down the x-axis, which doesn't exist just yet, so down, and then down here, and then we'll do a minus. That should compile. It should also, oh, it's not compiling in fact because I forgot to do that. Sweet. And then we can remove all of the braces here, make it shorter. Voila. And then what I think I'll do is try and inline this, see how that looks. What do we think? I think this looks good. The other thing I could do is have this, but then have it return a rover and only do that part. So really, this is like... I don't want to do that, in fact. The other thing I could do is say move to or something. You don't auto-apply a format that lets you forget about compact braces entirely. No, because sometimes it will do that stuff without me knowing about it, and then it might look... Because really, I could have gone either way with either the braces or not. So, yeah, now it looks nice. And if I want to do it, let's repeat that stuff. If I actually wanted to do it in a better way, I could have done... Oh no, I can't actually. Usually it says fix all things like that. So, but yeah, there we go. Okay, let's... I wanted to show you different styles. So this is move up Y or something, and then the rest will turn into move down Y, move up X, etc. But I'm not sure if I want to, and then maybe this we can inline. Yeah. But so if that's the case, then maybe why don't I just have a move function, really? Where we either say up or down, and then the axis that you want to move up or down. And then with that combined thing, we can change that stuff. I think it's already good enough, actually, like this. Maybe I do want to inline these, though. There we go, and then this one too. I think it's already clean enough like that. And then the other thing I still wanted to do was to make these beasts private, so that I don't accidentally use them outside of this position class. So that looks better. Better, stronger, faster. Let's run it again. Oh, what's that? I like to just set a config in the linter. Ah, yeah, and forget about it. That's also cool. Yeah. Yeah. No, you're completely right. Yeah. But I haven't really looked into if Kotlin has that sort of thing. Maybe you can do stuff like that and with check style or something. I remember, but I actually hate check style because it was blocking me more than it was helping me write good code. So I mean, screw that mess. Never using that again. We're in the green. We're in the green. Can move forwards up the... No, or actually down the x-axis. Here we go. So I think now we finally made sure that we fixed all of the move forwards. Not the thing I wanted. Now I think we can mark this as done. We can do backwards now, or we could do left and right, which might be a bit more interesting. Don't really know. Maybe it... No, let's do left. Or yeah, no, let's do left. This is good. Now what I like to do, since all of this stuff here is moving forwards, maybe what I can do is group all of these and then collapse them into one test block about moving forwards. So you can write nested, I think, and then have a static class. I think it's called. Sure, this is the one. And I want to say, or maybe it's not static. It should be class forwards tests or something. And then this one we put at the very bottom. And then format. And then this is non-static classes can serve as nested test. How did you fix that again? Was it internal? I do not remember. Non-static. Ah yeah, in inner, that's right, not internal. Okay, there we go. Now let's see if this still works. Let's rerun all the things. Yeah, 500k lines of codes. That's quite a lot, huh? All of the data scientists or the ML guys, they will be like, oh, you know what? Just run an algorithm. It will detect how to land autonomously. Listen, I don't know anything about that stuff, so. Here we go. Maybe we should call it moving forwards. And then rerun it again. There we go. Doesn't that look nice? Okay, now I guess what we'll do is inner class rotating left, yeah. Just load the model, that's it. Just load the model. Connect to AWS to make it to make it run. Oh man. Anyway, let's do rotate left. I already forgot rotating left. No, I really, honestly, my man is a Sif. Can receive a forwards command. Ah, yeah. Perseverance is awesome. No, can receive a. We forgot to commit. Left command twice or thrice. And change directions, maybe the thing that we want to test. Let's see what's in the commit. Yeah, nice. Okay, I will get rid of this bit. And then commit with the celebratory can do all the forwards movement. And in reality has actually landed. Ta-da! Amazing. Okay, I don't like this box because I want to go like option C or something. Maybe it just works. No. Pressing enter doesn't do anything. Pressing down doesn't do anything. Pressing tab doesn't do anything. I can only click on commit. So JetBrains, if you're listening, switch back to the regular dialogues, please. Or give us a choice. Maybe there is a choice and I haven't just found it yet. Already blaming IntelliJ. Nice. Okay, let's make a landed perseverance. Hey, we predicted the future. Where it landed at position 00. Actually, we don't really care how it landed. And it's north. And then what I can do, is something like this. I can say landed perseverance. So I suggest we keep on. Oh no, not left. It's still receive, and then now we need a left command. Right. So we can immediately assert on this is equal to a perseverance. No perseverance. Just want the constructor with position the same. 0, 0, and facing left. That means west, I guess. Right? So now this is nice because left doesn't exist yet. So we can, I guess, just add it here. And then import it. Statically import it. And well, the test should fail. But maybe we can already take a bit of a lesson from before. What I want to do is do like this basically. Have I gotten an M1 magnet? No, I haven't. I haven't gotten one yet. I think the lease on this thing is still another year, one more year. Call it rotated rover equals, and then we'll just call it oops, like this, and then we'll do it again because now I want to rotate this one. Call it rotated rover 2 is equal to, and now it should be facing south. And I guess what I want to do is do it again to rover 3, so to speak, and then, but what I can also do is something really cool using the also keyword. So instead of assigning it every time, you can chain. So really what you want to write is something like this. Receive left, receive left, receive left, receive left, and then here we want to assert what was it again? West is first, yeah, west, then south, etc., etc. And you can actually do that by chaining it with an also in between, and an also block takes in the result of this thing. So it's the result of the first receive left command, and what you can then do is basically write this. You can write the assert that, and instead of using the rotated rover, you just use it. Convert to single line, yeah. And now it reads kind of nice because I can do it like this, and then there should be south, east, and north again. And all of this carp can go. You just start from a rover that has landed north, facing north. So you can inline this, and it'll become quite clear that when you land your rover and you receive left, that it's equal to this one. That looks nice, huh? That's really cool. You can make it a bit more fancy, but I mean, this is already producing such nice readability value with just a simple keyword. I really love it. But now none of this stuff is working, so Let's run it. Let's run the tests to verify that it's indeed not working. It will fail at the first test if I'm correct, and not run all of them because I'm not asserting softly. So we expect we expect it to be facing west, but it's still facing north, so that makes sense because we haven't implemented anything yet. So here, this this becomes the move, in fact. And now we need to do something different when we've got a different command. And we've got a left command and a... What was it again? I want to see forwards and left. Okay, so let us start the other Astroneer playlist. Right. I pressed play, but nothing's happening. That's sad. Explosions? Yeah, I guess the second album is not working, so back to the first one. Now we need to take into account this command here. So what I could do again is if command equals forwards, I want you to do this, else to do implement rotate logic. Now it's compiling, but what we can then do is basically make this say move forwards. Look good? Look good? So in the same line, let's do rotate left. And then just create a simple function somewhere. Left. Which is always going to be returning a new rover, I guess, because we're returning something there. So, or sorry, a new perseverance. There we go. Return this. Now it should still be compiling. We can, I guess, also use a bit of inline stuff, but that we'll do later in a later step. Okay, same assertion error. So now we need to actually rotate. And I think what we can do is, let's first just make sure that we can rotate a facing direction. So we already know that we have to rotate left, which is actually counterclockwise. So facing, and then what we could do now is just like we did before with the position, move that responsibility of rotating itself to the direction itself, and not make that a responsibility of the Perseverance Mars rover itself. Even though that's the action that it's doing, yeah. So, but that's okay. What can we say? Oh, I just had an idea that I want to talk about after we finish implementing this. I will quickly write it down. Passing Perseverance as a receiver to facing direction. Yeah. Nice. We will think about what this implicates later. So this is going to be new direction. Then we will say, yeah, that will be a copy. we will leave the position alone, and we will only change facing using, again, the name parameter, and we will supply a new direction. Something is wrong here. Oh, yeah. This stuff is not compiling yet, so that makes sense. Rotate counter, or do like counterclockwise or something. Something like that. There we go. And here we can really just do a simple check when this, and now we will just, ooh, what's this? Let's do it like that. We'll add all, oh, say. Sorry about that. This. And then we just make it correct. Huh? So north should rotate or become west when you rotate counterclockwise. East should become north. South should become east, and west should become south. And then we need to return this. And then we can convert it into an expression body and make it real concise. Sweet. I think I've already implemented all of the rest now though. But we already had tests for that. That's nice. But we couldn't see them gradually fail and turn green. So that's my bad. Yay, that works. Yeah. This is already looking cool. Cool? So perseverance can rotate left to change direction. Then what's up next is, yeah, I guess rotating right. Maybe we'll just call this rotating then. And then right will be the complete opposite. We can just start at north and then right. So if you're at north, then this should be east, then south, then west, and then north again. Right doesn't exist yet, so let's create that. It's a command. Right. Yeah, guess what? We're going to add that as an import. As a static import. Then this test should fail, so if I run all of them again. So this does remain, even though it looks a bit silly, it remains important that it doesn't change position, right? Or she doesn't change position. What's next? Oh yeah, makes sense. This went wrong. I can't really see which one went wrong though. That's a bit annoying. Ah, there. If I click there, then it does show me where it went wrong. Alright. Let's make this a bit more extensive so we can return it, or return a when. Actually, I should have done this first. So now I can do, if it was left, then rotate left. If it was right, then guess what will rotate right? Rotate right. Which doesn't exist yet. We'll move here first. What do we do first? Maybe we can do that with this stuff as well. But first, let's try to do that. So rotate right. Here we will move clockwise. Clockwise is the other way around. Oh my god, I'm so sorry. C becomes east, becomes south, becomes west, becomes north. Run all of the tests again, and then we can do another refactoring pass. Okay, it's green. Okay, what I don't like about this is that these look exactly the same. They just end up working for another rotating command. And if we were to go like this, so if we would say when and then else, just pass along the command. In that case, we would, yeah, maybe I'll add it. We've got the command, and then here we can say if command equals left, then do this. Else we need to facing clockwise. And now this has become the rotate command. But let's make sure that this still works. Okay. Run the tests again, and it should still work. Yeah. But the thing I don't like about that is that I do an if and an else. So if I now enter a backwards command, which I haven't taken care of yet, it will move out of this forward, so that's not matching. Then it does match an else at the backwards command. Then it will try to rotate backwards. What does that mean? That makes no sense, right? So maybe I can do it again early like I did before. So if I say if my command is left here, or maybe also again replace it with a when, then remove these. Then if it's a right, I want to clockwise, and else don't do anything. It's just this dot facing, and then you basically don't do anything here. Now the thing I still don't like about that is that, let's say we're doing like half left or something. I don't know. Like let's make up a new rotating direction or rotating thing. Then I won't see, or my compiler won't tell me that I'm missing an exhaustive branch here. So really, I already explained it. What I'm really missing here is a more explicit rotating command. So here I want a Mars Rover, or the rotate function basically, to receive a rotating command, if that makes sense. And these should only be left and right. And when I have this, then it also must mean that this command here should also be only a rotating command, if that makes sense. And then I can do the same with moving forwards and backwards. So really a Mars Rover command is not just either forwards, left, or right. It's either a how do I write that down now? Either it's a move command and contains forwards or backwards, and is forward, or it's rotate and is left or right. Make sense? So the way you can do this in Kotlin is by introducing sealed classes. But I don't really know like a good way to introduce that. So I think I want to revert all of this crap. Yeah, and I'm afraid I didn't make a commit. Of course I didn't. That's still something I need to learn. Like, just before I start explaining something, let's make a commit. Then I can revert back to what I had before. Now to make sure that I didn't remove anything else. I think we're still in green, but let's run our tests for sure. To make sure. Yay! Okay. So basically this is can rotate right to change direction. Huh? So if we wanted to, we could stop here, but this is a code kata after all. And we still need to do this one in fact. But I already want to do a refactoring step, namely the one I just said. So how do we go about doing that? So let's just create a sealed class off on the side to this. Let's call it maybe just command for now. We can rename that later. And then a command consists out of either a dang it, how do you say that again? Or how do you type that again? I want to say it's either yet another sealed class. Does that work? Ah, maybe an enum, which is a move command, which is a command. I think that works. And then these can be, I need to call the constructor. Yeah, no. You cannot inherit from classes if you're enums. Okay, then these can be sealed. Yeah, okay, another sealed class. And then these need to be objects, which are singletons, really. They can only be instantiated ever once before, and then you use them like that. So basically they're just types that you use as their type. You can add some stuff on it, but we're not going to do it. So here we've got forwards, which is a move command. And we will have backwards, but we don't have that yet. And then we've got a another sealed class called rotate command, which is also a command. And this thing is either left or right. This looks good until now, I think. Okay, now we're going to do some magic, I think, because what I want to do is really replace this Mars Rover command with this one, and I can just change the type signature here into a command, but then these things won't work. Because the forwards here is still referring to this enum forwards. So what I can do now is this thing, oh no, I was gonna say it gets imported somewhere. That's this one, I think, that's causing the trouble. So what I want to do is maybe call this delete or something. Delete. Now I didn't do a rename, so now it just can't find this anymore. So now I can oh, I wonder, hang on, Hang on, maybe what I can do, I'm not really sure if this is going to work. Type alias forwards is command.move command.forwards. I wonder if this works. Ah. Okay. I guess I can try and do that. See if that does anything. Oh, it does actually. Okay, so let's try to do that. Also for left and right. Then the imports will get fixed, I hope. So I'm just doing this as an exercise or to show how you could easily do this refactoring. So really what we did is we had an enum class and we changed it into a sealed class, but I showed that you can actually you can do that in a safe way by using type aliases. Oh. Cheers, mate. See you later. Have a good one. And stay safe. Now I don't really. Yeah. So I can either tackle the complete command here now. And by the way, all of the above here is still working. I'm receiving left here, which is a type alias. I wonder if I can now inline this. That I haven't tried yet. Ah. Yeah, it doesn't work. That's too bad. Maybe if I do if I get rid of the enum class and then rename this thing into that, because the no, I don't want to do that. I also don't want to do that. So this remains the same, but the magic import does not work that way because there's a rotate command in between. Okay, that's too bad. So now I want to maybe import and then do like a wildcard import for this and for the, not the rotate, but the move command. Voila. Now we can get rid of the type aliases. Where are they at? Here. Bum. And we sort of need to fix this now. Okay, so it should still compile now. And my test should remain to be running. Sweet. Then next thing I wanted to do was we noticed that if you go to rotate left and rotate right, really it's exactly the same thing, but this changes depending on the rotate command really. So I want to replace left and right by calling a rotate, just a simple rotate function called function rotate. That takes in, and now we've got an explicit Mars Rover command. Let's call it rotate command. Dot rotate command, this thing, and it should return a perseverance again. We'll do return this, and then now we can move. how do you call it? Now what we can do is depending on the rotate command. So when rotate command, we need to return. When rotate command left, we can do rotate left. When right, we can rotate right. And you don't need an else branch now. Now we are exhaustive because we're taking in just a rotate command. And now what we can do here is if it's a rotate command, this command here, this one, then we can say if it's a rotate command, you can just rotate using command. Now I don't know what's going on. Maybe I can't have sealed classes here? I don't know. Okay, now I don't really know. I thought you could do this by saying when your Mars Rover command, no, I'm dumb, is a rotate command, then you call rotate with that command, and you can see it. It's green. It's highlighted in green. That means it's being smartcast. So at this point, the compiler knows, well, a command is not just a Mars Rover command. It's a more specific type of Mars Rover command. Namely, it's a rotate command. And that's why this signature just works and compiles. Cool, eh? And then the other thing we can do here is inline this stuff, because really it's the same thing. Here we will do the same. Then we will just inline this, and we will inline this as well. And now it looks quite neat. Maybe we can switch these around for better reading or readability. Okay, and then for this, I guess we can do the same, but first let's verify that our code is still green. That that's our green. So this was a noise refactoring. I guess this already was there. The left and right thing, right? What did we change here? Okay, so this was there before, but where we already had rotate right. Okay, nice. So this can be a refactoring. And then we can say introduced sealed classes to distinguish rotate commands from move commands. Voila. That we've also committed. And now it's looking quite okay, I think. Yeah, maybe one thing I still wanted to explore was this bit here. So maybe try passing perseverance as a receiver to facing direction. So what that means is, earlier I said I don't really like that the perseverance class or the rover class is responsible of doing the rotation. So I moved it to the facing direction, but I also don't just want facing direction, the clockwise and counterclockwise functions to be called by anything. I want to make sure that I first have that they can only be called within the context of a perseverance. It has its downsides, of course, because it means I can't just write this. Do stuff with road direction. I think it's called facing direction. So I can't just do, or basically what I want to do is I want to not allow this to just call it on its own. Why is that? Why do I not want that? Because the way I think about it is that facing direction is a part of perseverance. Maybe these can also be private. I forgot about that. Yeah, we forgot about that. What was it? Yeah, I think facing direction is like a part of perseverance. So updating it, which is really what's happening here. Not really, because they are value objects. But I feel like it's kind of weird to do this if you don't have a rover or a perseverance instance. So what I want this to turn into is you first need to have a perseverance. And a facing direction. Something that makes sense to this facing direction, I guess, of west then, I don't know. But now it's going to look really strange because how do you say that? This here it's facing west and I am calling clockwise on north, so it's kind of weird. So what I wanted to express was that you can also only call dot clockwise on a perseverance's facing direction. That's really what I wanted to do. And there is a way, I think, I might be wrong, I'm still learning. There's a way in Kotlin to do that, I think. Because I think what you can do is you can say to facing direction, hey, you can only call clockwise on an existing perseverance instance. And in that case, my code above is not going to be compiling. So what you need to do is the opposite. You need to call dot clockwise on a perseverance. Now you can see that this thing is still not compiling because okay, now I'm a bit confused. Ah, yeah. Yeah, no, that's not how you do it. I just created an extension function there. That's not what I wanted to do. So it's not this, but maybe it was something like, dang it. Yeah, I just forget. I forget how to do it. It's something like this. You call it a receiver, and then this is going to be a perseverance. And what you then should be able to do is when receivers facing direction equals this, then you get a new updated direction in return. And what you can then do is facing clockwise with yourself, but so then this doesn't make sense anymore. So that's also not what I wanted it to look like. Man. Yeah, I just forget. I forget. Revert. There was a way to express that, but I'm so sorry. Forgot. So let's not try to do that. And then what I still wanted to finish with is to implement move backwards. So we will copy all of these into moving backwards. We'll expand all of these, and then all of this will turn into backwards. And then we'll need to do some magic to backwards. Yeah. And move towards a new position. I guess, haven't we already? These are double tests, I think. Yeah, I think this one can just go. Or so that's north, south, east, and west. Yeah, this is becoming a duplicated test. We'll have the same one here then, since I copied it from there. Hey, we found a positive side of copy pasting. you read your code again and you learn what's wrong with it. Alright, so these will become backwards. That thing doesn't exist yet, so let's add it to the move command sealed class. Call it backwards. Nice. Voila. Now this suddenly has become exhaustive, non-exhaustive. So what I could do here to make it work is just say move backwards. This thing doesn't exist yet, so what we'll do is copy this and just say return this. There you go. Oh. Backwards. Voila. And now we need to reevaluate our tests again because I'm sure it's incorrect. So if you're going backwards, facing north, you're moving down the y-axis. If you're backwards facing south, you're moving up the y-axis. If you're backwards facing east, you're moving down the x-axis, and here it's reversed again. The backwards it already has, so now we need to flip these. There we go. And then this should become flipped as well. Okay, and now we run all of the tests. And all of the ones from moving backwards are failing, which is nice. Let's implement it like we implemented forwards, and then try to just make it work first. So north becomes moving down the y-axis, up the y-axis, down the axis, up the x-axis. Run the tests, and I guess it should work. And we might already see, so that's a commit, huh? Perseverance can, we already had like a move backwards. Yeah, what I was gonna say is that the facing direction we're always going to take into account. But the other thing is either you're moving forwards or you're moving backwards, and those things are going to decide if you're going up or down, I guess. So either of those things. Well, no, the combination of those things is what I wanted to say. So what I really wanted to look like is something like this. So when command is a move command, then yeah, this one. Then I want you to move using the command. Move doesn't exist yet. It takes in a move command. And it returns a new Perseverance rover. And then what I want to do here is return when CMD, yeah, basically this part. And we'll also remove the braces here. So that's already looking nicer. This is also, how do you say that? They also look quite alike. Like I just explained, if you're north and you're moving forwards, you want this to move up. We also noticed that this is a step here, so we could negate that, I guess, or reverse the direction. Because this would be the direction, I guess. All right. I think this is already good enough for now, actually. Some more stuff we can do is like easy stuff, convert it into expression bodies, and then it looks even more concise. This can be statically imported, and then this one we can also convert. And now we've got clear things, huh? Do stuff with the, yeah, this can, we need to get rid of that. That was just an example of where I wanted to go. Cool. Maybe we can do like one bigger test where we just check how a rover or a Perseverance can run around. Can receive, rotate, and move commands. End up and explore Mars. There we go. So let's land the Perseverance like the nice people at NASA did. Just a couple of minutes ago. No, I have no clue about time, so I'm probably incorrect. Now we can, I think, maybe write it in the style of these rotate things, so that it becomes clear what the position is intermittently. Is that a thing? So we've got a landed Perseverance. When they receive left, they should be at position 0 and facing west. If you then receive forwards, you should still be facing west, but you should be at -1. If you then receive yet another forwards, you should be at -2 facing west. If you then receive a rotate of right, the position remains the same, but you should be facing, north. And if you then receive backwards commands, you should, here you should be at -1, and here you should be at -2. And then maybe another left to end up facing north or something. I don't know. I think this is an okay test. Let's run it. Actually, if anything is wrong with this test now, it was wrong with the way I was thinking, right? Which seems to be the case. Where was that? Here. So we're facing north. We're facing north. Okay. Yeah, I mean, didn't update the other one. There we go. All right, cool. Maybe next time we'll implement. This can be done. We can do map awareness or something. This I think is a bit more difficult. This also more difficult probably, because we can split this problem up a bit. Okay, let's commit it. Perseverance can move backwards, and I guess what we did here was really just refactor a bunch. Or did we only just write the extra test? No, we did refactor. Okay, nice. Cool. Last, that's funny. Refactored. Move commands. Two separate method. There we go. We also added the scenario thing, so. Alright, I'm gonna make sure that I push this code somewhere that you can follow along. It should be at GitHub Scallop at the code retreat somewhere. Yeah, this one. You know what? I think. Yeah, nice. I did this one, so I will push it here somewhere. But in this time when I did the same code kata with Yo, we used that receiver function thing. So here it's a bit of a different approach here. But the implementation looks like we also had the move up on Y stuff here. Turn left and right on direction. That makes sense. But then here, yeah, okay. So if you receive forward, you want to move in the direction that you're in, but then applied forward. So what does that mean? Move is over here, which is an apply movement, which takes a function on a position that produces another position. So this is like a lambda stuff. And because this is declared as a function that you can call on a position, you can call it like this, which is very strange. Yeah, because you can just say this is actually this field right here. It's so cool. But that fixes that idea of I want something to apply a function that I as an object have created, because it's important that I am able to create that object, or that function, but I want to apply it to something else that's part of me. And that way you can have your direction here create have direction return a function that is applicable on a position. So what does direction dot apply forward look like? So if we've got an apply forward and it has a position, when I as a direction am north, then I want to return the functions move up on Y application, let's say. I wonder if I wonder how do you say that? How well you can do encapsulation with this, because you're referencing move up on Y, which is a public function. But I think you can make this internal and make sure that direction and position are coupled in that sense. So that you can really like make sure, well, I only want direction to make or to create function applications with receiver like this. Damn, this is so fucking cool. Anyway, I will upload it to this repository. Maybe I will link it. And then you can figure out which one of these branches the correct one is. And then I'll see you next Tuesday. All right, see you. Bye. Thanks for hanging out. Peace.